This video will be on section 3.1, an introduction to functions. The main topic, where actually I should have edited this out. We're not going to talk about the domain and range in this section. I moved that. We're just going to talk about the definition of a function and its notation, a function given a table or a set, a function given a graph, and then a function given a formula. So we just want to get used to all these things. Right, so what is a function? So a function is a set of ordered pairs which each x value, called the input, has only one corresponding y value, called the output. The x values are called the domain and the y values are called the range. Now that's important, so we'll say it now, but we won't be dealing with the domain and range until next section. And so a couple points to make about a function. Kind of the formal definition of a function is that it's a rule that assigns a single output to each input value. The notation for a function, you probably have seen this before, y equals f of x, is function notation. F is the name of the function, x is the input, and y is the output. So the input's what goes inside the parentheses. That's going to be important as we go through. And then the last thing I like to add in, because this is important when we do word problems, the inputs, the x values, are the independent variables because you can just plug in whatever you want. And the outputs, or the y values, are the dependent variables. They are the dependent variables because they depend on the x value. If you plug in x is something, that y value depends on it. So that's how you can remember what's independent and what's dependent. So what we'll do here, we'll look at a few problems, just understanding what is a function, what does it look like. The one we're going to use the most is the formula, but we won't look at that until the end. All right, so the wording for the definition of a function may be a little challenging. The easiest way to check is whether if any x value is repeated, the y value must be the same thing. Right, so every input, every x value can only have one y value to it. Right, so these tables are a good place to start. It asks which of the following tables represent valid functions. So the first thing you want to look for is if there are no repeated x values, it's automatically a function. All right, that's because if there's x values aren't repeated, then there can't be more than one y value. So if you look at the one on the left here, no x values are repeated. It doesn't even matter what the y values are. Since no x values are repeated, it is a function. All right, and we'll just I'll just go through all of them and check that. So the second one here, the x value of 2 is repeated, so I'm just going to leave that alone for now. The next one, the x value of 3 is repeated, so we'll leave that alone for now. And the last one, there are no x values repeated, so that one is automatically a function as well. So the other thing is, what happens if they are repeated? Well, if they are repeated, it can still be a function. So x values can be repeated if the y value is also the same, like I mentioned above. All right. If the y value is different, then it's not a function. For that repeated x value. All right, so let's look at our two remaining here. See, here we have x is 2 is repeated and the y values are different, 1 and 4. So it's not a function. All right, and what about the third one here? So we had x is 3 is repeated, and no others were repeated. But we notice here the y value is 1 in both cases. It's the same. So it is a function. Right, so most of the time when we deal with functions, we're actually just going to be given a formula f of x. It's automatically a function. But if it's not, we have to check that the repeats aren't bad. So 3 of these are functions. The first, third, and fourth one, this one here is not. Right, so one thing we can do before you look at the sets is evaluating functions. Use the table to answer the following questions. Evaluate h of 15. So what does this mean? Well, what goes inside the parentheses is x. And it's asking when x is 15, what is y? Or h of x in this case. When we look at our chart, we see x is 15 is here, and the y value is 18. So h of 15 equals 18. Now this is different than the second question here. The second question asks, for what values of x does h of x equal 15? So we want to figure out, we want to look at where h of x equals 15 and give the x values. Now to be a function in the first problem, there can only be one answer. But there can be a lot of x values that give the same y value. There doesn't have to be just one. We look here in the h of x column, we see 15 here, and we also see 15 here. And the x values are 12 and 24. So separate them by a comma. You might only have one, you might have more than two. That's okay. All right, the next one is just sets. They're coordinate pairs. So x comma y. If you think about them all as x comma y, so on, same idea from before. It asks which of the following sets represent valid functions. So we look for repeats of x values. We don't care about the y values being repeated at first. We just look for repeats of x values. The first one here has no repeated x values. So that means it is a function automatically. The second one, we look and we see that there is an x value repeated and the y value is different. It's 2 and 6. So it's not a function. It doesn't matter the way it's written. It can be written as sets, it can be written as tables. All the rules are the same. All right, the third one here, the x values -2, 3, 6, 7, and 10 are not repeated. So it's automatically a function. And then the last one, we see we do have a repeated x value. Again, it's 0. But the y value is the same. -2 and -2. So it is a function. Right, so same thing, whether it's a table or a set, we're checking the same things. Right, the next little section, we want to be able to look at a graph and tell whether it's the graph of a function. And some of you may be familiar with this, something called the vertical line test. So to determine if a graph represents the graph of a function, it must pass the vertical line test. And we say a function passes the vertical line test if any vertical line drawn intersects the graph up to once. So if it hits the graph more than once, if we draw a vertical line and it hits it more than once, it is not a function. Right, so I'll kind of illustrate that with these problems. So it says for the following graphs, determine if they are valid functions. This first one is a valid function on the top left because if we draw any vertical line, it's only going to hit the graph once. And it's hitting here, and here, and here, and here. It's good to go. Right. The next one over here is definitely going to fail the vertical line test. Even though it only hits one point over here, for example, we draw it, a line right there, a vertical line, it hits it more than once. It only has to be twice, but it can be 3 times. It fails the vertical line test. So it is not an answer. We would not bubble it in. When we have just points here, we just want to make sure the points don't lie on the same vertical line. If you're looking on the computer, I do find that sometimes it can be a little hard, so I just like to visualize drawing vertical lines and seeing that they're all different. So that one is good. The fourth one here, it's also good if we draw any vertical line, even though the line drawn is kind of steep, it's only gonna hit it once everywhere. The fifth one down here, if we draw vertical lines like we did before, we see that it's going to fail right here because it hits it twice. As soon as it hits it twice, it fails. We don't have to check anymore. And then finally, the last one, this V-shaped graph, also going to pass. Any vertical line we draw is only going to hit once. All right, now, I know some of you may have taken more math in high school. If you've heard of the horizontal line test, that is not relevant here. We do not care about horizontal lines. So don't worry about those yet. Right, but that's the only thing when it comes to the graph, function of a graph, testing whether it is a function or not, you do the vertical line test, that's all you can do. Now we also want to do a similar thing like we did with the tables. We want to be able to look at the graph of a function and answer some questions about it. So this one, we have the graph of a function right here, and it says evaluate g of 2. Right. So once again, you want to make sure you are careful with what you're looking at. This is telling you to look for the y value when x is 2. Right, so I go over to where x is 2 and I look up at the y value and I see it is 4. And that's our answer. G of 2 equals 4. The inside of the parentheses is the x value. The next one asks the question backwards. It says, for what values of x does g of x equal 2? So we want to find x when y equals 2. Right? Y is like the g of x. So what we do is instead we look at the y-axis, we go over to where 2 is, and then we go down to the x value, which is 3. So g of x, the y value equals 2 when x equals 3. You also notice that there's not another number. If we go left or right, we do not see the graph at y equals 2 again. It's just 3. Right, now the last little bit of this section is not much at all. This is probably something that a lot of you have seen before. Most of the examples we have in this class, we're going to be given a function, based on a formula, and we're not going to have a picture, we're not going to have a table, and we want to be able to evaluate or do some things with it. So this one here, I have a lot of parts just to make sure we understand everything. It says, given the function h of x equals 8x minus 3, evaluate the following. H of 0, so what that's telling us is plug in x equals 0 to our formula. We got 8 times 0 minus 3. 8 times 0 is 0. 0 minus 3 is negative 3. And that is h of 0. Next part, h of 2. What's on the inside is what we plug in for x. We're going to plug in x equals 2. We got 8 times 2 minus 3. 8 times 2 is 16. 16 minus 3 is 13. Now the next two parts might look a little weird, but if we follow what it means to plug in for x, we'll be all right. So this next one says h of negative x. What this is saying, I like to think about replacing instead of plugging in when I have letters here. But you can also say plug in. What we want to do is we want to replace x with negative x everywhere in our formula. So in place of x, we have 8x. I'm going to have 8 times negative x minus 3. Simplify this, distribute the 8 through, so you get negative 8x minus 3. And you're not going to get a number when there's a letter here. You're going to get a formula with that letter. And it's negative 8x minus 3 for this one. And then the next one here has x plus 1 inside. So we want to replace x with x plus 1. Right? Do not just do plus 1 at the end, because that is very wrong. What you want to do is, in place of our x, we have x plus 1. So we got 8 times x plus 1 minus 3 on the outside. Then distribute that 8 through, just like we did with the one previous, and we get 8x plus 8, then minus 3 at the end. And 8 minus 3 is 5. So we got 8x minus 5. And you must simplify these. If you leave this as your answer, it's not going to be marked correct. Right, and finally, the last one is similar to the idea we did above. It's telling us to find x when h of x equals 5. What that's telling you to do is plug in, replace h of x with 5 and solve for x. Right, so we're going to take h of x equals 8x minus 3 and replace the h of x with 5. I get 5 equals 8x minus 3, and now solve for x. Right, so we add 3 to each side. Got 8x equals 8. And then we divide each side by 8 to get x. 8 over 8 is 1, so x equals 1. And that's our answer for this one. Right, so as far as our introduction to functions goes, that's it. You want to really make sure you know what it means to plug, especially this last section. We're going to have a lot of problems in this class where we plug in not just numbers for x, but stuff with x in it. You have to be comfortable with what it means, what it's telling you to do.